Hey everyone, and welcome to This Explainer. I am so thrilled you're here today because we are going to dive into one of the absolute most vital, yet honestly kind of misunderstood mechanisms in pharmaceutical manufacturing. We are talking about FMEA, or Failure Mode and Effects Analysis. If you work in pharma, you already know we don't just hope for quality, right? We literally have to engineer it from the ground up. So today, we are going to explore how FMEA serves as the ultimate tool to essentially fireproof your plant, shifting your entire operation from just hoping for the best to meticulously engineering out the risk.
Okay, so here's the structured game plan for today. We'll cover the high stakes of pharma, decoding the risk formula, this step-by-step process, a real-world case study on hidden failures, and finally, winning regulatory audits. Let's jump right into Section 1, the high stakes of pharma and the true cost of manufacturing failures. Picture this for a second. Imagine a single, seemingly minor mechanical failure happens in your granulation suite. That one isolated little event can so easily lead to a $500,000 batch rejection. Or, infinitely worse, it could result in a contaminated product actually reaching a patient. The stakes in our industry are not just financial. They are literally life and death. The immense pressure to get it right every single time is absolutely real. So how do we actually prevent that $500,000 loss or that catastrophic patient outcome? Well, that brings us to the core philosophy of FMEA. Think of it like a pre-mortem. Traditionally, when a batch fails, a plant naturally asks, okay, what went wrong? But FMEA shifts our mindset entirely. Instead, we ask, what could go wrong? It forces us to proactively anticipate future failures way before they ever have a chance to manifest on the production line. And this really illustrates the core operational shift we're talking about here. Think about firefighting. That's the chaotic, reactive nature of fixing things only after a failure has occurred, eating up your precious time and resources. But then, contrast that with fireproofing. Under the ICHQ-9 guidelines for quality risk management, FMEA establishes a proactive quality culture. We are moving away from constantly putting out fires, and instead, we're engineering an environment where those fires literally cannot even start. Moving on to Section 2, decoding the risk formula, building your priority number, and establishing proactive risk management. First up is severity, or just S. Simply put, this measures the ultimate harm caused by the failure. Think of it this way. If this specific failure reaches the end of the line, how bad is the impact on the patient taking the drug or on the efficacy of the product itself? If a tablet is missing its active ingredient, the severity is massive, right? The second metric is occurrence, or O. This evaluates the frequency. Like, how often is this specific failure actually likely to happen in your facility under your current conditions? For example, if you are relying on older machines that kind of tend to drift out of calibration over time, your likelihood of failure, your occurrence score, is naturally going to be way higher than if you were running brand new self-calibrating equipment. And the third metric is detection, D. Basically, if the failure does happen, will our current systems and sensors actually catch it? Adding an inline sensor, for instance, significantly improves your ability to spot an error before the product ever leaves the line. That means you have a highly effective detection system in place. Okay, so here is where it all comes together. You multiply severity by occurrence by detection to calculate the RPN, or the risk priority number. This resulting number is absolutely crucial. It's your guiding light. It dictates exactly where a plant should prioritize its safety improvements and allocate its budget. You don't have to guess where to spend your resources anymore. The RPN tells you mathematically exactly where your highest risks live. All right, Section 3, the step-by-step process. Let's take this from theory to application. So how do you actually run a session on the floor? Here is your actionable 4-step guide. Step 1, assemble the Avengers. You absolutely cannot do this alone in a siloed office. You have to build a cross-functional team with diverse roles. We're talking QA, production, engineering, and microbiology. Having all these varied departmental perspectives is literally the only way to resolve conflicting risk scores. Step 2, map the process. Use visual flowcharts to break your manufacturing down into individual steps. This dramatically improves team collaboration by getting everybody on the exact same page. Step 3, identify the failure modes. And finally, Step 4, assign scores from 1 to 10 for severity, occurrence, and detection. Let's look at how this scoring system works in practice during a tablet compression step.
Say the failure mode identified is an underdose tablet. The cross-functional team agrees the severity is a 9 because, well, an underdose tablet severely impacts patient health. The machine is older and drifts, so Occurrence gets a high 7. However, the team recently installed a highly sensitive inline weight checker. Because this sensor is incredibly reliable, the detection score drops all the way down to a 2. Multiply 9 by 7 by 2, and boom, you have your localized RPN to guide your next safety steps.
Section 4. A case study on hidden failures, looking specifically at cleaning validation and cross-contamination.
Set the scene with me here. A multi-product facility in India is tasked with a super high-risk changeover. They are switching their manufacturing line from an ibuprofen batch over to a highly potent active pharmaceutical ingredient, or API. The risk of cross-contamination here is immense, and it means their cleaning validation has to be absolutely flawless.
Now, how does our mindset change this scenario? The reactive approach would be to just clean harder, right? Take some standard swabs from the flat surfaces and basically hope for the best. But using a proactive FMEA, the cross-functional team discovered a major hidden failure mode. Invisible dead legs in the piping or residue could easily build up. Because standard swabbing couldn't even reach there, they assigned a terrifying detection score of 10, meaning it was virtually impossible to detect a failure. Thanks to that massive RPN, the team didn't just generate more paperwork. They physically redesigned the plant's piping to eliminate those dead legs entirely, and they instituted a rigorous total organic carbon, or TOC, analysis. That is proactive quality management in action.
Which leads us perfectly into Section 5, winning regulatory audits and satisfying the USFDA and CDSCO. You know, international regulatory bodies like the USFDA and CDSCO demand dynamic risk tracking. This means your FMEA has to be a living document. If you install a new inline production sensor or upgrade your technology, guess what? Your detection score just improved. You must instantly recalculate your numbers and update that document. These continuously updated risk records are exactly what ensures smooth regulatory inspections because they prove active risk management. And that thought right there really hits the nail on the head regarding what modern auditors want to see. Passing an audit doesn't depend on having a giant dusty binder of static paperwork. It depends on proving a proactive, quality culture where cross-departmental teams take shared ownership of risk. Regulators want to see the evolution of your plant's safety driven directly by those recalculated RPN scores. When you can literally show an inspector that a high score led to an engineering change, which then successfully lowered the score, well, that is exactly how you win the audit. Wow, we have covered a lot of ground today, haven't we? From the basic SOD formula to navigating those high-stakes cleaning validations and staying audit-ready. Before we wrap up, I want to leave you with something to really reflect on regarding your own plant's proactive safety measures. Think about your daily operations, your equipment, and your teams. What is the absolute most common failure mode in your facility right now? Take that question back to your Avengers team this week, run the numbers, and start fireproofing your processes today. Thank you so much for joining me for this explainer, and keep engineering quality into everything you do.